great to have everyone here. I'm going to do just a really quick intro to both of these guys and to the webinar series. And it's really good to have everyone here. This is the first and hopefully longer series of webinars that we're doing with between IDEO and OpenZeppelin. And IDEO has recently started working more in the DeFi space. And of course, we have as well over at OpenZeppelin. We've recently completed several audits in the DeFi space, DYDX, Compound, Open, to name a few. And you're joined here today with Austin, who is one of our specialists in DeFi and one of our researchers. And I'll let both of you guys introduce yourself too, but I just wanted to give a quick intro to what we're trying to achieve here. We're really hoping to explore in a practical way some of the amazing things that are happening in this space. There are new things happening every day. As everyone here knows, you really got to pay attention within your 24-hour window, or you might miss something big. And
sometimes less than 24 hours.
Sometimes less than 24 hours. So that's really what this space is, a space to explore some of the practical code and how people can make use of that, some of the research that's coming out of our team, and then some of the research that is coming out of the teams that Dan is working with over at IDEO. Do you guys want to introduce yourselves?
Sure. Thanks, David. And I'm excited to be here. So to be clear, Austin is going to be the star of this show. He's the one who's doing the real research that we're talking about here. I'm on the IDEO Collab Ventures team. And so we do a lot of investing in early stage startups in what we talk about as distributed web. So there's a lot of DeFi, some kind of a little bit of layer one infrastructure, but more like broader technical and market infrastructure as well. And then we also look at kind of the future of work and play and how that's enabled by some of these systems. And so we generally invest at the pre-seed and seed stages. And so we see a lot of these projects very early on. And we've recently launched a DeFi residency program. We've currently got 4 teams in virtual residence with us, who are all, I believe, all pre-launch. One of them actually, I think, just launched an alpha recently. And one of the things we think is really important is security. And we've known, Austin and the OpenZeppelin team for many years. And we think that just there needs to be a lot of attention to security and to best practices. And so we wanted to work with OpenZeppelin on this webinar series to kind of help spread some of the knowledge and things that they're seeing and that we're seeing to kind of lift the whole community. So I'm here largely today to share some context from the things I'm seeing, and to the extent Austin's a very good explainer, but he's going to get very, very deep into the weeds, and I'm going to be kind of the person asking some questions to help pull us out and abstract away a little bit as necessary, but it'll be mostly him talking through this. Austin, you want to introduce yourself?
Awesome. Yeah, thanks. So I'm Austin Williams. I'm a security researcher at OpenZeppelin, and I'm just super entranced by DeFi right now. Lots of fun action there. So I spend a lot of my free time basically learning about DeFi, and recently, about a couple months ago, learning about backrunning and building backrunning bots as a opportunity and experience to learn how these things work, and just basically here to like brain dump today everything I know about backrunning. It's a pretty fun topic.
Great. Dan, do you want to get started with some questions, or I can jump in with questions as well, and then we can dive into some of the more technical side?
Yeah, so first, maybe Austin, you want to start explaining what backrunning is for people who aren't familiar?
Yeah, totally.
Because I think front running tends to be the more familiar term, right?
Yeah,
we think of people like racing to get there first, like back in 2017 was like get into an ICO first. And then more recently, like Uniswap trades, like you see a trade happening, and you try to get in there first, to get a better price before it moves in your direction or moves against you. But what is backrunning?
Yeah, so it's It's pretty much the opposite of front running, right? So like what you mentioned with front running, you're trying to get your transaction to be mined first in front of some other target transaction. Back running is the opposite. So you have some target transaction and you're trying to do whatever techniques you can to make sure that your transaction ends up being mined in the same block directly after the target transaction. So that's the short version.
And so what are some examples of like why you might want to be after rather than before?
Right. Yeah. So so sometimes some transactions, these target transactions, create opportunities that didn't exist before they were mined. So for an example that I work with a lot is price oracle update transactions. So you can imagine, for example, a price oracle update transaction may make an account on Compound available for liquidation. So there's a race among liquidators to be the first person to liquidate that account after the price oracle update has been mined. In other words, you want to backrun the price oracle update transaction with your own liquidation transaction. The liquidation opportunity like doesn't exist before the price oracle update is mined, so there's no point in front running it. You'll just be wasting your time and gas.
And so to be very clear, what we're talking about then is not just coming in after a given transaction. It's talking about coming in after a given transaction and before likely a whole flood of other transactions that are trying to also be the first one in after that transaction.
Exactly. Yeah, exactly. The rate you want the race starts with the target transaction being mined in the block, and you want it to end with you with nothing in between, preferably.
Okay. Yeah. It's a fine art to try to be after, but not too far after, right? Like,
yeah, it really is. Yeah. And, so this shows up in a handful of places. That's the one I'm most familiar with because when I was like doing side projects and to learn about this stuff, I was focusing specifically on backrunning price oracle transactions. But there are other opportunities as well that show up. For example, like if a large trade is made on like an automated market maker like Uniswap, that swings things out of balance, which means there's now an opportunity to rebalance for profit. So the large trade then is their target transaction, and you're trying to backrun it with a transaction that rebalances the pool, and you're taking all of that ARB profit there. And then a third one, I probably shouldn't even mention it, but with these like rebasable tokens, like Ample and dare I say YAM without us getting derailed, and Based and any other ones that do this like rebasing of the underlying units. There can be, depending on how the tokens and pools are set up, an opportunity. So immediately after the rebase transaction is your target transaction, and then you're trying to backrun that with a transaction that like skims a Uniswap pool or trades into the pool that is now like out of balance potentially, depending on how things are set up.
Yeah. Okay. So actually, that's kind of a fun one as maybe like a warm up. Is I think primarily today we're going to be talking about ways to effectively do backrun transactions, or like what that looks like, what strategies can be, and you can frame it. It could often be framed as like exploiting backruns, but it's like it's all fair game. It's out there. But I think one of the interesting things is like this is not primarily a webinar, hopefully, for people who are like arbitrageurs and trying to do this. We're talking to builders. And so one of the things that happened with the YAM contracts, right, is I remember we were talking about this, and you're saying like, oh, I think there might be a way to backrun this transaction, but then looking into it, you found that the developers on the YAM team had actually actively prevented that from being an issue in this.
Right. So at least with one pool. Yeah.
At least with one pool. Yeah. Right.
Right. The important one. Yeah. The very big one. Yeah.
Yeah.
Yeah. Exactly.
So there are some things where like if some of these games that we're going to talk about as a developer, if you don't want these games to be played because you think it would be detrimental to the system that you're building, there are ways to mitigate them, at least under certain conditions, to try to create a more level playing field or have your system operate closer to the way you're likely intending to design it.
Yeah, and that is like tangent to a point I want to make about sort of a philosophical difference between backrunning and front running. With the exception of this pool skimming thing, the overwhelming majority of actual applications of backrunning that I've seen are not, I don't know, for lack of a better word, like nebulously immoral, versus front running tends to have So with front running, you see a user sending a transaction, expecting it to execute against a certain state of the chain. And you're trying to front run them to change the state of the chain so that their transaction executes against something other than what they were expecting. So they tend to be situations where there is a definite loser, right? There's definitely someone who is expecting one thing to happen and instead something else happened. An innocent user that you're not someone you're competing against, just a good old fashioned normal user. Whereas with backrunning, you're not changing the initial state. The user's call is executing against a state that they expect. And in their wake, they have left a new opportunity that people are rushing in to fill. And so you tend to be competing against people that are on like a level playing field with you. So there seems there to be like there's like an interesting but nebulous, I haven't quite nailed it down, like moral difference between the two general approaches as far as like what this means and how this affects normal users of these systems.
Okay, so let me try to analogize that. Okay. So I guess the way I would think about it is like what you're saying is like front running. In some ways, what you're doing is akin to somebody is trying to like, they're trying to walk along a path, and they're expecting when they put their foot down that like the ground is going to be there. And as a front runner, you're trying to like move the ground and like make them like step different than they expected. But with back running, what you're essentially doing is you're saying like, oh, we see this like, maybe very large but not too smart whale is swimming through the water, and if we swim along behind him, there's like a race to eat whatever he stirs up.
Yeah, that's an
right?
interesting way of thinking about it.
It's kind of the way I would. Yeah. Okay. So you're kind of front running. I almost view as like you're kind of trying to mess with civilians, whereas back running, you're competing with other sharks.
Yeah, that's what it feels like, at least when I'm competing against backrunners, for sure. And when I see like the types of applications, I'm like, what kinds of things could I go after for profit with this new backrunning strategy? They tend to be things that are like expected to happen in the system. There are sometimes some exceptions to that rule, of course, but that's just a tendency that I've noticed in backrunning versus front running.
Gotcha. Okay, I think that's probably some like pretty good groundwork. David, are there things that you're thinking about like that we should be asking here, or do you think we can dive into some of the code examples?
Yeah, I think it's just how do we do it?
Yeah, excellent, great. So the methods change based on how miners decide to order the transactions in your block. This is just a transaction ordering problem. You have a target transaction, you have neutral transaction, you want them ordered in a certain way. So there's all of the power is in the hands of the block miners. And miners, of course, can order the transactions however they want. They have full control there. We can't force them to mine them the way we want to. However, in practice, they pretty much always order all of the transactions. They sort them based on gas price. There was a lot of opportunity for money there for them if they wanted mine them in different orders, but there just seems to be very little evidence that they're actually doing that right now. So currently, like at this time, that's one like assumption that backrunners rely on, is that the block miners are ordering based on transaction price. So a big important question to ask is, so when a miner has multiple transactions that have the same price, how do they order those in the block? That's like really the key to this whole thing. And the answer currently, like as of right now, is if they have multiple transactions with the same price, they order them uniformly at random. So if all of us send in right now transactions at the exact same price, it doesn't matter in what order they were received, or which spends the most gas. If they all have the same gas price, they're chosen uniformly at random and shoved in the block. So this informs how to go about backrunning under the current behavior of miners. So first, it's as a basic principle. Suppose you have zero competition and you have your target transaction coming in. It's some unique gas price, and I can then see that and then let's say send in a backrunning transaction to do whatever I want to do, liquidate or whatever. When the miner receives those two things at the same price, there's then a 50-50 chance that I'll end up behind them like I want, or in front, in which case I'll have front run them and not gotten it. You can scale this up then and say if I send several transactions, let's say 10 or 50 or 100 at the same gas price as the target transaction, and the miner receives them all, though uniformly at random, there's an extraordinarily high probability that one of my transactions will end up directly behind the target transaction. So I can increase my odds of this backrunning thing by sending several transactions that perform the same, let's say liquidation or arbitrage or whatever, from different accounts with the same gas price as the target transaction. Now, of course, everyone else knows this, and so they're doing the same thing, right? And so now if you send out 100 transactions and I send out 10, and the price all at the same price as the target transaction, when done uniformly at random, you're going to have much better odds of getting of backrunning it than I will. So there's this whole interesting game. There's an interesting like duality here between, it's a kind of auction in a sense, but it's different than the good old fashioned priority gas auction, right? Where like in a front running situation, priority gas auction, we are competing. Our bids are changing the price for a single transaction. In the backrunning case, our bids, if you will, are at least a hand wavy version of bids, is a fixed price, but our bid is the number of transactions that we send.
So it feels like backrunning creates a lot more potential like negative externalities for the network versus front running.
It's certainly a very inefficient way to right. So like at the same time, like, so the backrunners are paying for those slots, but right. So in that sense, it's like, is it spam? I don't know, but you can definitely say for certain that like if, in the case of like Compound, for example, they want someone to come in and liquidate as soon as someone's able to be liquidated. That protects the liquidity providers. So they want this to happen. But this is like a very inefficient way in terms of negative externalities, an inefficient way of achieving that. It would be much better if when the opportunity became available, people could do like a good old fashioned priority gas auction, where maybe they're bidding just as much that they're willing to pay, but it's manifesting as a single transaction with a small amount of gas versus a whole bunch of transactions. In other words, like it would be better if we could do this without having to like fill up a bunch of block space. And I can walk through an example actually where you can see this happening, and you have like 30% of the transactions.
Let's do that. That sounds, I think that would probably help crystallize this for people.
Sweet. Cool. So I took some time to find like a good, clean, like canonical example of a backrun that has happened. This is a backrun of a Compound.
I'm sorry. This is a clean.
Yeah.
Example.
This is a very, There are a lot of like messy confounding factors. Like sometimes, like when you're looking at a block, if the target transaction has a very round number gas price, it can be difficult to tell which transactions are attempted backruns and which ones are like are not. So
are just random, yeah.
There's a whole bunch of other weird edge cases, but I've like sorted all of those out to give like a nice clean example of like a single nicely contained one. So here's the story behind this transaction. And we'll look at its position in the block relative to all of the other transactions in a moment. I just want to give the sort of the story of how this transaction came to be. So this person, whoever was doing this, was running some bot somewhere monitoring the mempool. And at some point, Compound goes to update their price oracle sends an update transaction, price update transaction into the mempool. This bot, along with many other bots, see it before it's mined, and they compute which they check to see if after that's mined, there is going to be an account or multiple accounts available for liquidation on Compound. In this case, there was an account here there was a user who had put down DAI as collateral and borrowed USDC. So it's like a telltale sign of like a comp miner. The price up Oracle update happens, and all of a sudden this person is now no longer fully collateralized, sufficiently collateralized. So they're available for liquidation. Okay, cool. So this bot notices that, it sees an opportunity. It queues up all of the data it needs to liquidate this thing, and it sends it to like a coordination transaction. The coordination transaction for this particular bot is this contract here. I've tagged them. I've seen them many times before. I've tagged them as competitor with the first bits of their contract name. So this person sees this happen. They see the opportunity. So from an EOA, they queue up a call to this contract that passes all the information needed for this contract to liquidate the compound borrower, and they make basically send copies of this transaction from several different accounts. We'll see how many shortly. A lot of other bots are doing the exact same thing with a different coordinating contract. And all of these things are now in the mempool. The miners all see them all, and they see the price Oracle transaction along with like a flood of other, in this particular example, about 64 other transactions of an equal gas price of the price Oracle update.
Now, when you talk about a coordinator, what do you mean by the coordinator?
Yeah, so when normally if you're doing it like liquidating a compound account, an account on compound, like you just like call directly from your EOA to the compound contract.
From your externally owned account.
Yeah, from your externally owned account to the contract, giving the information like, I want to liquidate this buyer with I want to take this collateral, and this is how much I'm paying back. It's better if you do this through a coordination contract, because one of the things the coordination contract can do, remember, almost all of your transactions are going to fail. At best, one of your transactions will succeed, and all of the other transactions you send are going to fail. So you want them to fail cheaply. So what coordinator contracts will often do, at least if they're written like intelligently, the very first thing they'll do is check to see if the opportunity is still available, and then or if it has not yet become available. And if it's not available, then they just stop execution. They stop wasting gas, and they just sort of exit. If they and then of course if they see the opportunity is still available, then they go forward and then they like send the internal transaction to compound in order to liquidate. So it's just a way to like add some more strategy into your coordinator, into your bot system basically. But that's also nice for me as like a researcher. I can more easily find the coordinator contracts of all the bots, and so it's much easier for me to like go through Etherscan and see what is a backrun and what is not a backrun, and so on. So anyway, there's that. So when this executed, this person needed USDC, but they didn't have it. They had DAI. So their coordinator contract swapped the DAI they had for USDC on Curve, and then they had the USDC that they needed. So they sent it to Compound to liquidate that person's transaction. They picked up some free comp tokens on the way. They basically paid back 2,388 USD that was borrowed by that borrower on Compound. In exchange, Compound gives them the collateral that borrower was using at an 8% discount. So they received 2,559 DAI in exchange. So that is, at some point I ran this, that ends up being in the ballpark of an 8% profit. You can see they paid, for the privilege of this, they paid transaction fee of like $41. And so they made a decent profit here. It's not bad. Of course, that profit does not include all of the other transactions they sent that lost money by burning gas. So it's you know, but still, this is a positive for them. Okay, so now let's see like where this fits in the rest of the block. So we can copy the transaction hash here, so we can search for it when we have a list of all the transactions in the block. We can dig into the block here on Etherscan. We get all this information about the block. This one was mined by Bpool, which means that at the time this happened, we know that Bpool is still doing things uniformly at random. Doesn't necessarily mean that, but they were. So, and you can see in this block, there were 212 transactions. So we'll look at a list of these transactions. So this is Etherscan showing us all the transactions in the block. If you're not familiar with this view, they're ordered the opposite of what you would think. This top transaction here, for example, was the last transaction mined in the block. And this was the second to last and third to last and so on and so forth. So this goes on and on for several pages. I know because I checked before we started this that the transaction we're looking for is on, I think, page 3. Oh yeah, I'm on page 4. There we go. So here's the transaction that we were looking at. And you can see it was mined immediately after the Compound Oracle transaction. So the Compound Oracle transaction was in the pool, mempool. This person saw it. They could see that the gas price they were using was 92.4 Gwei. So they constructed their liquidation transaction and broadcast it out. Now, I've actually gone through the effort. I recognize a lot of these coordinator accounts as liquidator contracts. Apparently, I'm not logged in anymore. Let's log in so we can see my labels that I've added. Boom. Okay, this is the same thing we were looking at before, but now you can see all of the labeled contracts I have. Here's the Compound Oracle update. Here's the transaction that was successfully backrunning. This was our competitor, 0x7b2ef. And look, you can see 2 of his transactions, the same person came in, actually probably more, there's more on the other page we'll look at, came in before the price oracle update, and several of them came after. Several of these attempts. This one succeeded, of course, and none of these did. You can see other coordinator contracts were being poked at the same time. All of these, if you look, you can check, all of them are using the exact same gas price as the price oracle update transaction, which was the whole point of this thing. And if you can look, like, they start here, all of these were attempts. Every single one of these transactions were attempts at liquidating. That one was successful. And if you go to the next page, you can see there were, look at every single one of these that are highlighted and tagged are backrun attempts. Yeah, every single one of them. And you all the way down to here. This is the last one, 92.4 Gwei, and then there was some other stuff going on. So there were 64, I counted earlier, I think, transactions attempting to backrun this thing, which amounts to about 30% of the transactions in the block. Most of them fail fast, so I really don't know what percentage of gas in the whole block was used in this sort of very inefficient way, but at least 30% of the block. Now, this was a clean one in the sense that all of these attempted backruns ended up in the same block. Sometimes, when you're looking at these situations, you can look at the next block and you'll see some more attempts that just didn't get mined into the same block. In really extreme situations, I've gone like 20 blocks forward and 20 blocks backwards and still found attempts being mined that were targeting the one individual transaction, over 130 something attempts to liquidate.
That was people not using coordinators to like cancel transactions?
So they were using them, but for whatever reason, the miner, when the miner like grabbed the set of transactions they were going to mine, they hadn't seen some of the other ones that came through. And also sometimes, because remember, like, we can't crank up the gas prices on these things. So sometimes the minimum price to get into the next block will be higher than the target Oracle transaction. So which means your other attempts will not get mined until the gas prices come back down. And yeah. So anyway, that's about all I have for an example.
That's very cool. So to summarize, what we just saw was a typical Oracle update, which opened up an opportunity for liquidation to occur, and then we saw a whole bunch of different essentially liquidation bots, backrunning bots, running and sending a whole bunch of transactions, broadcasting a whole bunch of transactions that were all, at least from each bot identical to each other, likely almost identical to across different bots, all just hoping that whoever mines that block that the Oracle update is in happens to randomly place their transaction after the price update.
Yeah, exactly. Yeah,
okay.
And it's like a super lucrative thing. Like, so it is not uncommon to see several times per month a successful backrun transaction getting like tens of thousands of dollars in profit. Like, so not in like proceeds, but like in profit. People who get those tend to be, a bit more aggressive. And I should point out that not all compound liquidations are backruns. There some smaller, maybe 20 to 30% are. It's been a while since I've looked. a lot of them are triggered by different, a lot of times accounts become available for liquidation for reasons other than the price updating. It's usually like interest accrual, like the interest will accrue, and then at the beginning of a new block, an account is all of a sudden available for liquidation.
Okay, so in that case, it would be more of a front running situation.
Yeah,
I
would say, but like I would say more specifically like a priority gas auction situation, because you're not like trying to get in front of any particular transaction. You're just trying to be like first in block.
Okay, yeah, that makes sense. Okay, so I guess it looks like we're getting a couple questions that have come in. So the first is, the more popular this gets, the harder it's going to be to succeed, right?
Yeah. So the more expensive it gets to succeed.
Shouldn't this eventually get competed down to like there should be effectively no expected profit on this?
Right, exactly. And hopefully it doesn't get to that, because then you're going to have like this like floor gas price below which no one was going to be able to get any mine. But yeah, it does. And compound's like super, super competitive. It's slightly less so now that the gas prices are so high. A lot of bots, including my bot, just like they'll say, hey, I have this opportunity here, but like to even send it to even get it mined would require more gas than I have in the sending account. Because remember, you have to have like many, many, many sending accounts. So whatever capital you have willing to put into this, you have to split it up among all of your different accounts. And this is a hobby project of mine. I'm not going to put like tens of thousands of dollars in ETH on like some Amazon server hotkeys for, I'm not going to do that. So like I get priced out pretty quickly. A lot of bots have been priced out pretty quickly, but they're still playing. Yeah, people are still doing it. So to get an interesting answer to that question is that yes, it does get more competitive. It does get more difficult. And there's some fun, at least to me, like if you like math, it's a fun exercise to figure out the so given some estimate of how many competitor transactions you're likely to see, and knowing the cost of succeeding, and knowing the cost of your transactions failing, try to compute the optimal number of transactions to send under those assumptions to maximize your expected value. Yeah. It was super fun. It was like the most fun coding I've done in a while. Because you can almost certainly guarantee you're going to win if you send out 1 million transactions.
But it might not be worth winning at that point.
Exactly. You're paying
a cost for it. Yeah.
You're going to be paying a cost on all but one of those to get them mined. So it's fun.
Well, I definitely encourage people to ask questions if you have them here. One clarification that if you could clarify, Austin, you were mentioning, you showed those transactions that had the same gas price before the Oracle update. How did those end up in front of the Oracle update?
So they, because they were priced at the same price. So you have like a pool, all these transactions, all those ones that I had tagged. Yeah, exactly. So they still get mined, they still get executed, just not in the order that you had hoped. Like they end in a different place in the block than you were expecting.
So they're very ineffective. They're completely ineffective if they end up ahead of it in the block.
Yeah, exactly. And the coordinator contracts are at least most of them. There are a couple oddballs, but like most of them are smart. They like check, hey, has the price oracle been updated yet? And if not, then it just stops spending gas, and usually they don't revert. They just
that makes sense. So when I'm starting to think about this, and or I've been thinking about this, but the two areas that spring to mind is one, you said this is how it works right now, where it's random ordering. And is there a reason you say right now? Are there any changes that are on the horizon?
Oh yeah, that's so very recently. So this was noticed, and some people were like, hey, these externalities are not good. Maybe we can take away this incentive. So it seems to be the case that most miners are using like default geth, or at least they're ordering uniformly at random for same price transactions. So the assumption is that they are. So like the geth devs were like really quick to respond to this. There was like an issue created, a proposal made, a PR, and then it was like done. So if and when the miners decide to accept this new update, so the new way they'll do same price transaction ordering is first in, first out, by first seen, the first ones that they saw. So this, if they do accept it, and they do it, I have no doubt that so the backrunning as a strategy will not go away, but this particular manifestation of it, where you're like sending out lots of transactions to try to get the backrun, that will go away, because you're either the first one that they see after your target, or you're not. And if you're not, there's no point in sending 500 transactions in an attempt to win. So it shifts the game. I'm on the fence over whether or not it's a good idea, because so I definitely think it'll work, but it might be like out of the frying pan into the fire. So for example, so now it turns the game basically into like good old fashioned high frequency trading stuff, where you're looking for very low latency detection time and communication with miners. Now that could manifest in a very polite way, where people are not doing like network level attacks, or it could manifest as network level attacks. And so what worries me a little bit is so right now it is at least equitable in this, not really, it's whoever throws the most money out of it, but your expected value is proportional to how much money other people have put in. Whereas the first in, first out situation, it's a winner take all situation. You're either the fastest and you get everything, or you're not the fastest and you get nothing. So the people who are confident that they can be the fastest, they have a lot of incentive to put a lot of resources in this. Hopefully they'll be smart and like not be disruptive about it, and not try to do things like eclipse attacks and blah, blah, blah. And like intentionally throttle, like have a whole bunch of nodes that are highly connected, and then like slow down or throttle their opponents' transactions and stuff like that. Because of course, if they invest that much time and engineering into doing it, and then they start to be disruptive to get an edge, like, remember, this is not like a consensus rule. You just change this and geth again, and then all of your efforts go away. So like, hopefully it will come to some sort of like, I don't know, reasonable, non-malicious equilibrium.
And also, one thing you mentioned, an eclipse attack. What is that?
It's very unlikely to happen in practice. We can get partial eclipse attacks and stuff. So the idea is that in a P2P network, and if you have a node, an eclipse attack is where, so the most naive basic version is where every connection from your node is to a node that I control. So I control your view of the whole network. You don't see a transaction unless I relay it to you. And in that sense, I could just like block all of my competitor transactions and relay only my own and my target transaction directly to you. They're very difficult to do in practice. You can do partial ones though, where like maybe 99 nodes out of the 100 of yours that you have set up are nodes to me, or maybe like I'm not directly connected to you, but I'm surrounding all of your neighbors. Again, not easy to do, but we're talking about like millions of dollars a month in potential profit for on the order of tens of thousands of dollars a month in operational costs. So it's possible.
Okay, so it's likely to get, that sounds too juicy. It's likely to get competed down over time in some way, shape, or form.
Probably. Yeah.
So you mentioned that, it's awesome that the geth devs can just like kind of deploy some hot fixes. Like, you still need to wait on the miners to adopt them, but this isn't a consensus change, so it's not a lengthy, painful governance related process.
Yeah.
Which is, it's interesting because it does seem like it very much has implications for the health and functioning of the network. It just happens to occur at a level that is not consensus code.
Yeah, and it's not super clear that it will be terrible. I as a security auditor, I'm like hyper paranoid about everything, so I just assume the worst. It could be fine. Like,
so it might be fine. Okay, hopefully it's fine. The other thing is, like, this is an attempt to fix it. Do you think there are better ways to go about doing this that are better for the health, likely better for the health of the network?
I don't have any ideas. If I did, I would have dumped them in the GitHub issue. Some of the other ones that were floated were like sort by lowest transaction hash instead. And so then you could, if people wanted to compete to be positioned differently, they would have to basically mine, if you will, lower transaction hashes. So all kinds of interesting things like that.
Introducing like proof of work effectively into the
in this kind of a weird way. Yeah, another one was like,
that's fascinating.
Yeah, another one was like, just go with the whatever address, like read the address as a number, and whichever one is the smallest number, do that first. Then you can imagine people like mining to create the smallest address that they can, and they all have like interesting different trade-offs. I think probably the biggest difficulty in deciding the best one is like knowing like, what are we trying to solve for? Like if all we're trying to do is stop the transaction flooding, then like the choice that was made will work fine. But like if we're trying to optimize for like being equitable and a fair distribution of the profits that are available, then like you probably would make different decisions. So like I think there's like not consensus on like what the design goal is, other than just like not the current thing because we don't like the current behavior.
So that feels like, I mean, an idea we love talking about, the design principles, right? And so that sounds like a systems design principle here, right here, or mechanism design principle too, is to think about like what you ultimately care about and are trying to accomplish, right? It's easy to say, this is not ideal, but understand not ideal why, like clearly identifying the problem and then kind of coming up with multiple potential solutions to address that problem, not to try to stop the behavior altogether because like we can't, right? There's too much economic incentive, but like what are the negative externalities it's creating that you can attempt to address through a better solution?
Yeah, and this is an attempt to address it at like the default miner level. Like miners again can do things however they want. So walking out on an edge here, people probably disagree, but from my view, miners are like absolutely not behaving in like in a rational, self-interested sort of way. There's a lot more money they could be making that they're not, and instead they just run like default geth. So this is like just sort of like a clever way of saying, oh, if they're running default geth anyway, then we can address this at the geth level and just make this non-consensus changing change, and then voila, problem's fixed. And so that's an interesting solution. At a higher level, you can, like at the app layer, you can have the developers can make design decisions. For example, Compound is hoping to eventually move towards this like open Oracle model where anyone can submit the price Oracle update as long as the price Oracle's the price has been signed by one of a trusted third-party member, like Coinbase or something. So when they make that switch, for technical reasons we probably don't have time to go into, this backrunning opportunity goes away entirely. And there will still be opportunity, of course, liquidation opportunities won't go away. Those will always be there, but you won't be able to take advantage of them by backrunning anymore. Instead, it'll turn into like a good old-fashioned priority gas auction situation where I see the price that was signed by whoever. I realize that if I submit that price, this account will become available for a liquidation. And so in a single transaction, I submit that price update and also liquidate that account. And that whole transaction has a gas price that I decide. Everyone else sees the same opportunity, all the other bots, and so they're also making equivalent ones. And we're all now competing over a single transaction, cranking up the gas price to be first. So the problem goes away then.
Oh, interesting. Okay. So you're still competing, but I know you don't like the term front running, but like because it's not. But effectively, that's you're trying to front run all the other folks who are competing.
Sure. Yeah, you can
just to be first in the block, right?
But the point is, everyone competing is submitting a single transaction, and then they're bidding over how much money how much of their profits they're willing to give to the miner.
So that
instead of
so I guess so one of the kind of design principles to think about too when you're designing a system where you expect there to be arbitrage opportunities at various points, like sounds like there's a couple design patterns that you can use that would be helpful. One is to let whatever function operation would open up these arbitrage opportunities, make it simple that it can be packaged in with in a single transaction with whatever's going to arb it back into a market neutral state.
Exactly.
And then that makes it that's kind of like being a good citizen for the network, effectively, right?
Right, exactly. There are maybe some like second order effects, reasons why they might want to do that other than being a good citizen. For example, when you have like 200 transactions that are the same price as your price Oracle update on chain, it can delay the amount of time it takes so there are like small reasons for them to do it, but like if most of the least bigger project developers,
that's even better, right? That's even because then you're not thinking about like, oh, I should do this altruistically. You're saying like actually it's in your incentive. It's aligned with your incentives as the person who's designed this protocol. You actually want fewer transactions.
So I think it's like something that like maybe a lot of like protocol designers like aren't thinking about. So it's nice maybe if this gets in front of them, it's on their plate, it's something they can keep in mind, and they're like, hey, we want this to happen. Like their system's going to work properly either way. But if they can make like a small change so that you know, all of this negative externality doesn't happen, then why not?
That's very cool.
Great. I think I see a question here that's thank you guys both for diving into that. There's a question here just about the ecosystem as a whole. I'm wondering, Austin, because you've been auditing several of these DeFi projects, just what your take is on the space as a whole and security in the space and where we can move with that.
Yeah. Oh man, it's wide ranging. It's all over the place. So there's a wide range of quality with respect to security in the space. Like the compound contracts are so well thought out, and the DYDX contracts, balancer, they're just like, so there are design decisions here and there that people can make differently, but as far as like the understanding of what's happening like at the solidity level, it's getting more and more mature over time, which is really good. It's not universal. There are cases where people have put in a lot of effort and they put stuff in front of us that is like unnecessarily complicated. I think a lot of it, my guess is a lot of it comes from like traditional programmers that are new. They're good at programming, but maybe not, they don't really understand like the severity of the irreversibility of the blockchain. And so they maybe are I don't think they appreciate how important it is to keep things simple. So they're long story short, wide range of differences. But I do see generally speaking things getting tighter over time.
Oh, Dan, I think you're muted there.
Thank you. Yeah. I remember seeing, I think it was OpenZeppelin report on one of the compounds. It was like the governance migration or something like that, and seeing it was like the first one to like completely clean report. It was like no issues at any level of severity.
I was auditing on that one.
Oh, okay.
I remember thinking at the time when I was giving it to him, I was like, they're gonna think I didn't look at it. So I had like a conversation with him. I'm like, this is a super clean report. Here's evidence that I actually dug deep, and like, it's like talked about subtleties and stuff just to convey that like I wasn't sleeping on the job. Like it's just good code.
Yeah, and there's a couple notes at the end. It was like, here would be some best practices, a couple things in the end, but like it was all like, nothing to worry about. Yeah.
I would add the warning not just a plug to keep getting audits, but like definitely don't let your guard down, because it doesn't take like small little changes and then users' money is gone. We see that a lot.
Yeah.
Just be careful still.
Yeah, and I guess to that end, like, as OpenZeppelin, I think people tend to think of OpenZeppelin and other audit firms as like it's kind of a process you go through before launch or before major upgrades, and it kind of gives the team confidence, it gives the users more confidence, it's all that. But like, are there other ways that you also like to interact with teams that you think can be a better way to, is there a way to do it on like a more of a kind of continuous basis with you guys?
Yeah, so it's like an ongoing thing, and I think the security space is maturing in that way, and you're starting to see more services offered, trying to make contact with the developers earlier on in the process, so they can help guide and things that are very hard to change after the fact, like architecture decisions and things like that. Testing is getting a whole lot better. The cost of audits is still very high, just because like the tooling space is getting much better, but the tooling space is tools in general are limited. They can only take you so far, and with DeFi in particular, the business logic is so complicated and so interrelated that it just takes a lot. It's a lot of very manual thing, just going through line by line, building the mental model, and finding all the levers and trying to break it. So one thing I like hope for the future is that somehow we find some combinations of tools and protocols for auditors to help bring down that cost. Because if the barrier to entry to like make a cool new thing and then put it out there for people is like is like absurdly high, and you can't launch without like VC funding or something. Like that's not like the open economy that we were envisioning when we all got excited about Ethereum when it first launched, right? So like it's very important because like you don't want people to lose their money, but at the same time, and like it's a very difficult manual process. Definitely aided by tools, and like Trail of Bits has done great jobs with the tools. MythX, like there are fantastic tools out there that help, but they only get you so far. And there's like a huge component that is still just very like laborsome, if you will, just going through line by line. So that's one thing I hope to see in the future.
All right.
Sorry, go ahead. I was going to ask for any kind of last questions.
Great. I think we're good here then. I want to thank Austin for that awesome presentation, diving into it. Dan for making this happen and getting here and being a champion all around. So thank you guys so much. And everyone who made it and who joined, thank you guys for joining. We'll be doing these more frequently. So we really hope that you guys can join in the future. And we will be putting the full recording out as well, so you can see that.
Awesome. Thanks, guys.